Let us move on to the next question, that is question number 66, which says that let fx is equal to minus 3 when x goes from minus 2 to 0, and it is equal to x minus 3 when x goes from 0 to 2. And gx is equal to f of mod x minus mod of fx. Then the area bounded by the curve y equal to gx, x-axis, and the ordinates x equal to plus minus 2 is. To find the function gx, let us firstly find f of mod x. To find f of mod x, let us replace x by mod x. So, it is equal to minus 3 when mod x is going from minus 2 to 0, and it is equal to mod x minus 3 when mod x is going from 0 to 2. Now here in this interval it can be observed that mod x is negative, which is not possible. Hence this will be discarded. Hence this is equal to mod x minus 3 when mod x goes from 0 to 2. That is x goes from minus 2 to 2. Right. Now this can be written as mod x will be equal to x when x is greater than 0, and mod x will be opened as minus x when it is less than 0. So this is equal to minus x minus 3 when x goes from minus 2 to 0, and it will be equal to x minus 3 when x goes from 0 to 2. Right? Similarly, we will find the function mod of fx, which will be equal to mod of minus 3, that is 3 when x goes from minus 2 to 0, and this will be equal to mod of x minus 3. Now when x goes from 0 to 2, then mod of x minus 3 will open as 3 minus x, right, when it goes from 0 to 2, right. Now the function gx can be calculated as f of mod x minus mod of fx. So this is equal to minus x minus 3 minus 3, that is minus x minus 6 when x goes from minus 2 to 0, and this will be equal to x minus 3 minus 3 plus x, that is 2x minus 6 when x goes from 0 to 2, right. Now let us make the graph of this function. This is x-axis and this is y-axis. Now to make the graph from minus 2 to 0, the graph would be something like this, where this point is minus 2 comma minus 4 and this point is 0 comma minus 6. Similarly, graph can be drawn in 0 to 2, because at x equal to 0, y is minus 6, and at x equal to 2, y is minus 2. So this is something like this, and this point is 2 comma minus 2. Now we have to find the area bounded by the curve gx, x-axis, and the ordinates x equal to plus minus 2. So we have to find this area. Now these two are trapezium, so the area can be written equal to half into sum of parallel sides, that is minus 4 plus minus 6, taking mod of that it will be 10 into 2, plus similarly the other one, that is half into 2 plus 6, that is 8 into 2. So this is equal to 10 plus 8, that is 18 square units. That is the correct answer, is option number 4. Next is question number 67, which says that if integral 1 to 2 x into ln of 1 plus 1 by x into dx is equal to ln of root k upon 4, then k equals. Now this integral can be solved by integration by parts, right? Whenever we have mixture of two types of functions, then we use eyelet, right? So this is equal to integrating this and differentiating this, we can write it equal to x square by 2 into ln of 1 plus 1 by x minus integration of x square by 2 into differentiation of this will be equal to 1 upon 1 plus 1 by x into minus 1 by x square into dx. Now cancelling minus by minus, we will get plus and x square can be cancelled. So this is equal to x square by 2 into ln of 1 plus 1 by x plus 1 by 2 into integration of x upon 1 plus x into dx. Here subtracting and adding 1, we can write it equal to x square by 2 into ln of 1 plus 1 by x, applying the limit here from 1 to 2 and here also, right, plus 1 by 2 into integration of dx, that is x, minus integration of 1 upon 1 plus x, that is ln of 1 plus x, and the limit is from 1 to 2, right. So this is equal to, applying the limit, we will get 4 upon 2, that is 2 into ln of 1 plus 1 by 2, that is 3 by 2, minus putting x equal to 1, we will get 1 by 2 into ln 2 plus half into, here we will get 2 minus ln of 3 minus half into 1 minus ln 2. This is equal to 2 times ln 3 minus 2 times ln 2 minus half into ln 2 plus 1 minus ln 3 upon 2 minus half plus ln 2 upon 2. Now here these two terms can be cancelled. So we can write it equal to, with ln 3 we have 2 minus 1 by 2, that is 3 by 2 into ln 3 minus 2 into ln 2 plus half. Is that clear? Now this can be written equal to, taking 3 by 2 in the power, we will get ln of 3 raised to the power 3 by 2, that is 27 root minus ln of 4 plus ln of under root e. So this can further be written as ln of under root of 27e upon 4, which is equal to ln of root k upon 4. Hence the value of k is equal to 27e, right? So the correct answer will be option number 3. Next is question number 68, which says that if 1 plus x raised to the power n is equal to nc0 plus nc1x plus nc2x square and so on, then summation of summation where I is greater than equal to 0 is less than j is less than equal to n ci cj equals. So we have to find the value of, let us put j equal to 1. So I can only be equal to 0. So that is c naught c1 plus, taking j equal to 2, we will get c naught c2 plus c1 c2 plus, taking j equal to 3, we have c naught c3 plus c1 c3 plus c2 c3 and so on. This is what we have to find. Let us say this is equal to s. Now we know that c naught plus c1 plus c2 up to cn whole square is equal to c naught square plus c1 square plus c2 square and so on, plus 2 times c naught c1 plus c naught c2 and so on, that is 2 times s, which we have to find, right? Now let us find the value of c naught plus c1 plus c2 plus up to cn first. It can be found by putting x equal to 1 here. When we put x equal to 1, we will get 2 raised to the power n equal to nc0 plus nc1 and so on. Hence the value of this is 2 raised to the power n. Now we have to find the value of this term. This can be obtained by taking two expansions, that is 1 plus x raised to the power n is equal to c naught plus c1x plus c2x square and so on, and we can write 1 plus x raised to the power n as this also, that is c naught into x raised to the power n plus c1 into x raised to the power n minus 1 and so on. Now if I multiply these 1 plus x raised to the power 2n, and if I ask for coefficient of x raised to the power n in this. So this will be equal to c0 square plus c1 square plus c2 square and so on, right? So this will be equal to coefficient of x raised to the power n in 1 plus x raised to the power 2n, which is equal to 2n cn. In equation 1, putting the values, we will get 2 raised to the power n raised to the power 2, that is 2 raised to the power 2n is equal to 2n cn plus 2s. That is, the value of s is equal to 2 raised to the power 2n minus 1 minus 2n factorial upon 2 into n factorial into n factorial, right? So the correct answer will be option number 2. Next is question number 69, which says that for any two real numbers p and q, let us define a relation r dash as p r dash q if and only if sine square p plus cos square q is equal to 1. Then the relation r dash on r is. We have to tell that the function is whether reflexive, symmetric or transitive, right? Now let us start with reflexive first. The relation will be reflexive if the given equation is true if I put p equal to q, right? Now putting this, we will get sine square p plus cos square p equal to 1, which is true for all p belongings to r, right? This is always true. Hence, the relation is reflexive. Now, next, let's talk about symmetric, right? As it is given that sine square p plus cos square q is equal to 1. So, this can be written as 1 minus cos square p plus 1 minus sine square q is equal to 1. Cancelling 1 on both sides, it can be written as sine square q plus cos square p equal to 1. That is, the relation is true for q r dash p also. Hence, the relation is symmetric, right? Now, for transitive, let us say p r dash q and q r dash r are true, right? So we will have sine square p plus cos square q equal to 1 and we have sine square q plus cos square r equal to 1, and we have to prove it for p r dash r, right? That is, we have to eliminate q from these. So if I add both these equations, we will get sine square p plus cos square q plus sine square q will be equal to 1 plus cos square r is equal to 2. That is, sine square p plus cos square r is equal to 1. Hence, we can say that p r dash r is also true, right? So, the relation is transitive also. Hence, we can say that the given relation is an equivalence relation. That is, correct answer is option number 4. Next is question number 70, which says that the angle of elevation of the top of a TV tower from 3 points ABC in a straight line in the horizontal plane through the foot of the tower are alpha, 2 alpha, 3 alpha respectively. If AB is equal to A, then the height of the tower is. Let us say this is the tower and these are the three angles alpha, 2 alpha and 3 alpha. AB is given to be equal to small a and we have to find the height of the tower, that is h. Now here let us assume this is PQ, right? So we can write tan alpha as PQ upon AQ. It is equal to PQ upon AQ can be written as A plus BQ. Similarly, we can write tan 2 alpha as PQ upon BQ. Now we have to find the value of PQ in terms of alpha. So from equation 1 and 2, let us eliminate BQ. So we will get A into tan alpha plus BQ into tan alpha is equal to PQ. Let us write PQ as H. And from equation 2, we have BQ equal to PQ upon tan 2 alpha. So from here, let's put the value in this equation. We will get A into tan alpha plus PQ into tan alpha upon tan 2 alpha. Tan 2 alpha can be written as 2 into tan alpha upon 1 minus tan square alpha equal to H. Cancelling these two and multiplying the equation by 2, we will get 2A tan alpha plus PQ can be substituted as H minus H into tan square alpha minus 2H equal to 0. Hence we can say that 2A into tan alpha is equal to H into 1 plus tan square alpha. That is, H is equal to 2A tan alpha upon 1 plus tan square alpha, which is equal to A into sin 2 alpha. So the correct answer will be option number 3.